Imagine you are at a party and someone opens the freezer. Suddenly, all the ice cubes start melting and the room gets warmer. Now, picture that freezer being the size of a continent and the ice cubes being ancient carbon locked away for millennia. Welcome to the world of permafrost thawing, a global phenomenon that's not just about rising temperatures but about unleashing a cascade of environmental consequences. What is permafrost anyway? Before diving deeper into the issue, let's understand what permafrost actually is. Permafrost is a layer of soil, rock, and sediment that has remained frozen for at least 2 years. It covers vast regions of the planet, particularly in the Arctic, where it stretches across millions of square miles. In these regions, the ground is literally locked in time, preserving plant material, ancient microbes, and even animal remains that have been trapped in the ice for millennia. Permafrost isn't just really cold soil, it's a repository of carbon. During the Ice Age, plants and animals were frozen before they had the chance to decompose. Fast forward thousands of years, and that organic material has built up in layers, all of it now locked away under permafrost. As the planet warms, the thawing of this ground releases the organic material, and with it, carbon and methane that have been stored for an unimaginable length of time. A warming Arctic. In recent decades, the Arctic has warmed at a rate much faster than the global average, about 4 times faster, according to recent studies. In 2024, we saw record high temperatures in regions where permafrost exists, setting alarm bells ringing for scientists monitoring these areas. Thawing permafrost is no longer a slow, creeping process. It is accelerating at an alarming rate, and this is partly due to the increased global temperatures that result from human activities like burning fossil fuels. As temperatures rise, the permafrost that once stayed frozen year-round begins to thaw. This not only changes the landscape, but also releases the carbon and methane that were previously trapped. The faster the thaw, the faster these gases are released, leading to a vicious feedback loop that exacerbates climate change. In short, the Arctic is warming, the permafrost is melting, and we're seeing the effects firsthand. The carbon time bomb. Now, let's talk about the real kicker. The carbon that is locked away in permafrost. Scientists estimate that there's around 1,460 to 1,600 petagrams, 1 petagram equal to 1 trillion kilograms, of organic carbon buried in the Arctic permafrost. This is more than double the amount of carbon currently in the entire Earth's atmosphere, which, needless to say, is a bit concerning. As permafrost thaws, this carbon begins to decompose and is released in the form of greenhouse gases, primarily carbon dioxide, CO2, and methane, CH4. But wait, it gets worse. While carbon dioxide is a significant contributor to global warming, methane is even worse. Over a 20-year period, methane is about 84 times more effective at trapping heat in the atmosphere than carbon dioxide. So when methane is released from thawing permafrost, it acts like a turbocharger for climate change, accelerating warming at an even faster pace. The timing could not be worse. If methane continues to be released at accelerated rates, the results could be catastrophic. Methane, the silent saboteur. Methane does not get as much attention as carbon dioxide, but it's a major player in the climate change game. As permafrost thaws, the ground not only releases carbon dioxide but also methane, which is far more potent in terms of trapping heat in the atmosphere. If you think of greenhouse gases as the culprits in a global heating event, then methane is the villain that lurks in the background, quietly escalating the situation. As permafrost thaws, pockets of methane stored in the soil are released into the atmosphere. This release of methane is often abrupt, creating a feedback loop. As the Arctic continues to warm, it leads to more methane being released, which further accelerates warming, which then causes even more methane to escape. It's a vicious cycle that becomes harder to break the more it continues. The release of methane also impacts the Arctic in other ways, like affecting the chemistry of the atmosphere and ocean. This can lead to changes in weather patterns, potentially altering everything from the frequency and severity of storms to the seasonal migration patterns of animals. While it may seem like a distant issue for those of us living in more temperate climates, the impacts of this process are global and will affect everyone. The tipping point dilemma. What makes the situation condition so dangerous is that scientists have yet to pinpoint an exact tipping point when permafrost thaw will reach a threshold that causes irreversible damage. However, they do know that multiple regional tipping points could trigger catastrophic changes. For instance, if large sections of boreal permafrost, the type found in northern forests, collapse, it could release massive amounts of carbon and methane, dramatically affecting global climate systems. Once the thaw starts, it becomes increasingly difficult to reverse. The Arctic ecosystem, which has been frozen for thousands of years, is changing rapidly. As these changes continue, they'll alter the composition of the atmosphere and ecosystems around the world. This uncertainty makes the issue even more pressing, as we're dealing with a system that is constantly shifting in ways that we cannot always predict. Wildfires, an uninvited accelerant. In recent years, wildfires have become a common feature of the Arctic landscape. These fires are intensified by the warmer temperatures, which not only dry out vegetation but also provide the perfect conditions for fires to spread rapidly. The alarming part is that these fires aren't just devastating to the forest itself. They also release even more carbon into the atmosphere, which contributes to more warming. But it doesn't stop there. Wildfires in the Arctic have the added effect of exposing permafrost to the air by burning away the insulating layer of soil and vegetation. This means that once protected permafrost is now exposed to warmer temperatures and will thaw at an even faster rate. It's a deadly combination. Wildfires release carbon and methane, and they accelerate the thawing of permafrost. Infrastructure at risk. As if all the environmental implications were not enough, permafrost thaw also poses a direct threat to human infrastructure. In regions like Alaska, Siberia, and parts of Canada, much of the infrastructure, including roads, buildings, and pipelines, was built on frozen ground. As that ground thaws, it becomes unstable. This leads to sinking roads, leaning buildings, and even collapsed bridges. In Alaska alone, it's estimated that thawing permafrost could cause up to $4.6 billion in damage to infrastructure by the end of the century. This has serious implications not only for the residents of these regions, but for their economies as well. Governments and businesses are already having to spend billions to retrofit infrastructure to withstand the changing conditions. And if permafrost continues to thaw, these costs could increase exponentially. The global implications. While the impacts of permafrost thaw are most immediate in the Arctic, they have global consequences. The release of carbon and methane into the atmosphere will not only accelerate climate change, but could also drive extreme weather events, food and water insecurity, and loss of biodiversity. As much as $43 trillion in economic impacts could occur by the end of the 22nd century if current trends continue. These costs will likely affect everyone, no matter where they live. Rising temperatures, more frequent extreme weather events, and the loss of arable land will result in massive disruptions to economies, livelihoods, and public health across the globe. What can we do? Addressing the issue of permafrost thaw requires a multi-pronged approach. First and foremost, we need to focus on reducing global greenhouse gas emissions. Limiting the extent of global warming will slow the rate at which permafrost thaws, giving us a better chance of managing this process. In addition to reducing emissions, we need to monitor and study the thawing of permafrost more closely. Researchers and scientists are working on developing new methods for tracking these changes in real time, which will allow us to anticipate and manage the consequences more effectively. Finally, we must adapt our infrastructure to the changing landscape. In regions affected by permafrost thaw, building and maintaining infrastructure that can withstand shifting ground conditions is crucial. This will require investment in resilient technologies and adapted strategies to minimize the damage caused by thawing permafrost. And that's a wrap on the chilling reality of thawing permafrost. If you learned something new or just found the idea of a methane-fueled climate crisis kind of wild, hit that like button and subscribe to stay up to date on all things climate related. Got thoughts on permafrost? Drop a comment below. Maybe we'll even start an Arctic debate down there. Thanks for watching, and remember, stay cool, but not too cool.